So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 54 and in this video we learn again some operators. In this case the logical operators, which you can see here in the middle. It is this exclamation mark, this double and sign and this double pipe sign, what we have here. And they are called, let me click this one and we see it, they are called negation operator. It's the exclamation mark. Sometimes it is also called not operator, something like that. And then we have this AND operator, this double AND sign. And then we have this inclusive OR operator, this double pipe sign here. So, and how we use this operator in C++, let's get into it. But before we get into it, we will not discuss the theory behind that here in the practical use of C++, because this one you have to do again on your own, on online documentation or on a C++ book, where this kind of operators are described more in detail and more accurate, because we as a programmer, we want just use them very fast and without thinking too much, but still all with full correctness. So let's get into it. We have here again these operators here a little bit, and how they are called: logical not and logical inclusive OR. But important is here you will see when you try to learn them some tables, and these tables are telling you what they are doing actually. So for example, here this logical let's start here with this logical not operator. We have here a variable a, and then it says here something true, false, and when we use this logical operator, it turns down, it turns the opposite, it creates the opposite. So the logical not operator is like it says here, a negation, and it means just says the opposite what you say. If you say true, it will say false. If you say false, it will say true. And then we go here to the AND operator. Then we have here B says here true, the B says here false, then A says here true, and A says here false. And here in the middle, what you see here is the output for the AND operator. And here you can see the AND operator will only say true when both are true. So when B says true, A says true, then the AND operator will say true, and all other cases it will say false, false, false. That is the only thing what we remember as a programmer here, and all other things are not so important. And the next thing is for the OR operator. You see again the same table like before. We have here A can say yes, true, A can say false, B can say true, and B can say false. And in this case, the OR operator is almost the opposite, right? When we watch this table here, it says almost all time true, only false when both says false. So, and this kind of stuff we will just remember as a programmer, because we will not remember really this table here, because that's too much work. We as a programmer want to go fast, simple, and with one idea, so we can concentrate on our job and not on encrypting tables or something like that. So let's get into it. Here I have write the operators as a comment: the AND operator, the OR operator, inclusive OR operator, and the negation operator. Then I have created here two bool variables, and I call them true bool, true, false bool. For false, careful, don't irritate with these names, because they are called false bool means not they must have the value false, that they can have also true. And to demonstrate these operators, these logical operators, one good way is use a if statement. Why? Because the if statement has here a condition, and this logical operator create a condition. Yes, so let me go fast here again to this table. This true and false and false and false and so on, what you see here in the middle, these are the end condition which the logical operator is creating. And what I mean with that, let me explain it here. So let's get started. And we start not with these variables which I created here, we start with hard-coded values, and we talked about hard-coded values. I hope you still know what hard-coded values are. Hard-coded values are just numbers instead of variables. And here I use hard-coded values because it's easier to demonstrate. So I start with 1 less than 2. This is my first condition. And then I use this AND operator. Okay, let's use it. And then I write again a hard-coded value, which is 3 is less than 4. Perfect. And now what we see here is the if statement is interested. So the if statement starts here. Let's make it a little bit more visible. So the if condition is here, and this one is what I wrote here. So we start with the if condition. The if condition is only interested in the end result, like we learned the if statement, right? It is only interested in the end result, what comes here out. So if it comes true, the if will go to the true block. We learned this. And if this here comes false, the if will jump to the false block, in this case the else block. I think the if statement you already know. The only new thing is that we have now here more conditions to check. So, and that's very important, because how we are checking these conditions. First of all, remember one more thing, something like precedence. Precedence means what comes first, what comes later. And that will be later very important. And in general, the solution of this is we use this round brackets, what I used here, which means when I use this round brackets, I know this round brackets has a very high precedence. Let me show what I mean with this real strange word, precedence. So here, operator precedence, right? This word here, perhaps I pronounce it totally wrong, but it means which operator comes first, which comes later. And you can see here this round brackets actually has a very high value, right? And here the highest is this double colon, the scope resolution operator, and then all the other things. And you can see here this AND logical AND operator, which we learned today here, is 40. And interesting is this OR is behind this one. And then also interesting is the negation operator is very high, is on rank 3. So we have here on rank 3, which means this one comes before the AND, before the OR. And this is important for our ordering when we here evaluate these things here. And let me show you what I mean with that. So it starts here with 1 is less than 4. I say here yes or false. In this case, I would say yes, right? The compiler will say yes too. And then it goes here and checks this variable also. 3 is less than 4. And it says yes, okay. And this AND operator will now create the last condition. What I mean with that, the last condition, this say yes, but now I will use both of your conditions and I create the last condition. Yes, yes is a yes. So we watch this table. The AND table is here. They call yes is the same as true, so true is true, and that's it. That was it. What the AND do. But I said a programmer don't think in tables, right? Tables you learn only at start to understand how all things work, how the theory is, and so on. But as a programmer, that would take much time if I really think in tables. So what a programmer do is we make it very simple. When you see just this AND sign, you have just to know if one side says no, this will say all time no. The logical operator will all time say no, and that's it. That's enough to know because then you know when both sides say yes, it will say yes, and when one side or both sides say no, it will all time say no. So this is like let's say like more a programmer things. So we don't care about these tables. We know this little logic which we use is fast and is all time right. So let's see if I'm really right. Let's change this to 5. Right? And what happens now? Let's repeat what I said. A programmer says if when I see a AND operator and one of this condition says no, this whole thing will also, this logical operator will say no. That means it will jump to this one, and when we start this program, let's see if it jumps there. Indeed, it was false. And why? It says here yes, okay. Then it says here no, okay, but logical operator says, checks now both conditions, yes and no. I found one no, okay, jump to the no. So that's very simple, and it's a same trick we use actually for this inclusive OR, right? We don't think in tables. The tables you have to learn if you never worked with logical tables, I mean with logical operators till now, but later if you have this, when you see something like this in programming, you know this is almost all time true. When one of this side is true, it's all time true. So I have only find one of these sides to be true. But if I find both false, then it will be false. So very simple. What I do here is I check, is this true? Yes. The 1 is less than 2. Yes, it's true. True means yes. Then I check here, 5 is less than 4. Is this true? No. But what is the end result? Because this one is a OR, I need to find only one true. I found one. This will put out this one. So I think not much. I don't think in tables. Yes, it was true. Perfect. So I make my life very easy, very simple. And of course, if you are a beginner, you have still to train this, but later it's really simple. You see it, you check only, you check first what operator this is, and then you know I have to see if one is true or one is false, and that's it. And let's make the last operator as well, which is the negation operator. And this one is probably the easiest operator. Why? Because it says just, it say, doesn't matter what you say, I will create the opposite of what you said. So for example, this one says 1 is less than 2. Yes. And when I use now this negation operator, it says I will create now the opposite, which is false, which means this one will print out. And we see this one is indeed printing out. So this one is very easy. When you see an exclamation mark, it's printing out the opposite. So now let's train this fast with this variables, because what I used here was hard-coded values. Hard-coded values, like I said, a programmer should not use hard-coded values when the variable is changing. They use most time hard-coded values when they know these values will never change. They are constant, something like that. And even then they use not hard-coded values, because then they use const variables, something like that. But anyway, what we are going to do is now using variables, and in this case this true boolean and false boolean. And like I said before, careful, don't be irritated by the name. This can still be true if I use, for example, this exclamation mark, right? Let's start. So I write here true, this true bool, I take this true bool, and now I test it again with my AND operator. Let's use this one, an AND operator, false operator, false bool. So, and actually, when you see something like that, you should be able to identify it very fast. And the reason is very simple. When you see an AND, I said, a programmer say just, I know when 1 is false, this will be false. All will be false. So, and this false boolean, I know there is false, and I don't need to check even this one here. That's the nice thing. You don't have to, because when you see an and you find one false, this will be false. I jump directly in it, and when I check it, yes, it was false. And the same goes for the other way around for the inclusive OR. I think not there much. I know here I just find one true and it will be all time true. So in this case, true boolean is here. I don't need to check even this one. So a programmer would even stop thinking here, and you know this will be true. Later when you have training, at start as a beginner you have not a training, but later if you have a training, then this will be easy. But what happens now? Now let's make a little bit tricks, which you will see also. What happens if I use this exclamation mark? Can you think about this fast too? Sometimes yes, sometimes not, because this one is still a very easy example, because here I have false. This is a OR, which means I have still to find a true. So I still have to check this one, but this is a true boolean, and negated is false. And this time I know both are false, which means it will go jump to the false. Yes, this is a little bit training here because kind of stuff, but it's very simple. At start, after you trained this, sometimes you see you will make this very easy. Let's change this to a and. What happens here if I change this to a and? Very fast training. What do you think? When you see a and, what you have to check? If one of this is false, then it will be all time false. So this one is already a false boolean, I know. Even I change this one, I don't care about this one because I know this one is already false. So I don't need to check this one, even I change that and it will be false. So this is so, yeah, thinking without tables. But I said thinking without tables means not that we have not check all conditions, because this one is a very fairly easy example. We can make, of course, this a little bit more difficult. But this, I'm not sure if you should make very difficult examples in coding, but in general you should not make this, because coding is not like encrypting training, because in coding you should try to focus on fast solving your problem and not doing something like that what I'm going to do now. And that is, I write here something like and or true, but this happens sometimes too when you have really many conditions and so, but in general, yeah, I don't know if you should make this one, this kind of coding. And then I make here false. So what I did here is, let's make it not too complicated. What I did here is I just added logical operators one after another, and now I have a problem. What is the problem? It is fairly not very easy readable and not so easy checkable. Now I have think a little bit more. Why I have think actually a little bit more? The problem here is, first of all, it's actually easy. I can start from in front, and then I can say, hey, turbo bool is true, negation is false, and the end, then can I false bool is false. So what we have say, when we found already a false with a false, this will be false, and that's the problem. Perhaps I can't do this. And why? Because in this case, probably I can, because of this one, of this precedence operator. Sometimes you can't do this because you have really check if you can do this. For example, here in this case, you really can do this, but if I change this one here to a OR, inclusive OR, let me change this one to this one and this one to this one, then we have already a problem. Why? Because this one is right. This one comes before all other things here. So this one comes here. But when I go here on without thinking, then I would get here true bool becomes false. And I have just to check if one of this one is true. And this one is also false. So I know this one becomes false. and then I go with false with the true bool. So I know here if one of with an AND is a false, it becomes false. And I made a mistake here. So what is the mistake? The mistake is this one comes, I have to do this one before this one. Perhaps the outcome is still the same, depends on the thing, but still it was a mistake that I have to do this one before this one. And you see what I mean, right, with this operator precedence. And to solve this problem in programming, they use all time this round brackets to make it sure that the point what you want to be first, that it comes really first. For example, let's go here through about this example. So here I made the mistake that I said I go here and to do this one, and this is a false, okay, and this one is a true, is both false, so this one becomes false till here, and true false is still false, and here if I have already a false, I even don't care about this one, is all false. So in general, I would say this one print out false. Let's check if it's true. Probably yes, but must be not. That was just randomly generated. Yes. What I mean with that is when we have here something like a and could be other way around. Yeah, that's not so. Why I'm here down, I don't know. So the important thing is to avoid this problem. What comes first? What comes later? What comes then and then? And so what you have to do is use this round bracket, what I wanted to tell you. For example, in general, this one would not come here after. Let's make this here round brackets. And now if you take now this one, so now you make sure that this one will be evaluated first, and then this one, and then connected with this and later at the last point. And here you have to do again this logical thing, but they are at the same level, which means they don't care. But this one will be evaluated first, then this one, and then this one and this one. Yeah, and to make it sure, make all time, like I said, set the things what you want to be first in this round brackets, and make sure that they follow the rules. So with that said, I stop this video, and if you have any questions, you can ask them in the comments. And yeah, bye for now and good luck.